Hello guys, today we are going to discuss about multiplier bit-pair recording. This is the concept which is useful in both multiplication to reduce the number of summands to n by 2 for n by n multiplication and also to perform the high-speed multiplication process. To understand this concept, let us take two numbers. If a and b are two numbers, a is assumed as multiplicand and b is assumed as multiplier. Each have n number of bits. Always we have to maintain the same number of bits for both multiplicand and multiplier. That's why it is called as n by n multiplication. Now, when we multiply n by n multiplications, then it gives n means, suppose if I take the n equal to 4 for multiplicand and for multiplier also 4, then if we take the binary form of the numbers 1001 with 4 bits and 1100 for the second bit for the multiplier. When we multiply these two binary values with 4 bits, which provides 4 partial products. These partial products also called as summands. If the number of bits in multiplier are increased, then the number of summands also should increase. After finding all the summands, we should add these values to get the final product value as result. Now this is the procedure of multiplication process of two numbers. When we perform the multiplication of n by n size, that means 4 by 4 or any size, then we will get the n number of summands. Suppose if we use the bit-pair recording procedure, then we will get the half of the number of summands. So for that we should follow the bit-pair is the speed of multiplication process. Now let us see one example. Here this is the example of how to write the bit-pair recording for the multiplier bits with the help of both recording. Now these are the multiplier bits 110, 10. The leftmost bit always specifies the sign bit value. This is 1, that means a negative signed multiplier value. That's why it is negative sign, so that we have to extend the sign bit one more bit towards the left side. And to convert these multiplier bits into bit-pair recorded values, now we should append one more 0 towards the right side. There are two methods. The first method is first convert the given multiplier bits including appended 0 and 1 into 1 bit recorded multiplier bits. Then from those 1 bit recorded values, we should find the bit-pair recorded values. Now to find the 1 bit recorded values, take the difference between two adjacent bits from right to left. 0 minus 0 is 0. 0 minus 1. This is the difference. That means it is minus 1. Similarly, 1 minus 0 means plus 1. Again, 0 minus 1 means minus 1. 1 minus 1 means 0. 1 minus 1 is 0 again. So these are the bits obtained with the help of the 1 bit recorded values of the multiplier. With these multiplier values, now we should find the bit-pair recorded values. Now we should make these values into groups with 2 bits each. Here the first 2 bits 0 minus 1 plus 1 minus 1 0 0. Now we should assign the binary weights for each group 2 power 0 and 2 power 1. Similarly 2 power 0 and 2 power 1. This is 2 power 0 and 2 power 1. Now we should multiply the quotient values with the corresponding binary weights and then add for each group. For the first group it is minus 1. Minus 1 into 2 power 1 plus 0 into 2 power 0 means 1. Now its value is minus 2 plus 0. So that its value is minus 2. Similarly for the second group, easily we can find minus 1 into 2 is minus 2 plus 1 into 2 power 0 means 1. Its value is minus 1. Similarly for the third group, both are 0, so that the product will be 0, so that the final value sum is also 0. So 0. These are the bit-pair recorded values for the given multiplier bits. So this is the way of writing with the help of the first method. Okay. Now let us move to the second method. This is the second method of finding the bit-pair recorded values for the multiplier. Now let us take the multiplier bits again. 1 1 0 1 0. These are the multiplier bits. This is a sign bit, leftmost bit, negative. These are the 2's complemented values. Now we should append the 0 towards the right side, and as it is a negative sign number, so that we have to append one more bit towards the left side as a sign extension. Now first we should divide into groups. 3 bits as one group. This is first group. Again this is another group. Again from this point to this number, this is a third group. Now we should write the 100. Here you can see the table. Here there are 3 bits because we are divided the multiplier bits into groups with the 3 bits. That's why the positions of the multipliers are I-1, I and I+1. Now with these 3 positions, we can write the binary combinations in 8 ways. The first number is 000 to 111. That means 0 to 7 total number of combinations should be 8. Now, just by splitting this group into 2 groups, in the first group, the values are 0, +1, +1 and +2. In the second group, for the remaining 4 values, -2, the complement of the above values and write in reverse order. -2, this is -1, this is -1, this is a 0. Nothing but is without writing binary also you can write the only equivalent decimal values 0, 1, 2, 3, 4, 5, 6 and 7. Now divide into 2 groups. Now we should write 0, +1, +1 and +2. For the remaining second group, -2, -1, -1 and this is 0. Now it is easy to write the equivalent bit pair recorded value. 100 means its equivalent value is 4. So for the 4, its equivalent value is -2. Now 101 means 5, -1. Now 111 means last combination, its value is 0. These are the bit pair recorded values. Directly we can write with the help of this table. Okay, so in this way we will get the same answer using the single bit recorded method, and also with the help of a table directly we can write. This is one example. Here we have 2 numbers, +13 is multiplying with the -6. First we should write these 2 numbers in binary form. Plus means 0 sign bit, 13 means 8421 based on the binary weights. We should write the binary equivalent 1101. Similarly, -6 minus means 1 sign bit, and for 6 the binary is 0110, but it is a negative signed number. That's why we should represent in 2's complement form. The 2's complement value for the -6 is 0101. That's why we should written as 1010. These are the binary equivalents for +13 and -6. Now, here we can see there are the multiplication of these 2 numbers using both multiplication with the help of 1-bit recorded values of the multiplier and 2-bit recorded values of the multiplier. Now, let us do the first method of multiplication. Now, we should convert the multiplier bits into 1-bit values. The multiplier is 11010. Now we should convert into 1-bit recorded values as by inserting the or by appending the 0 towards the right side and sign bit extension towards the left side, because this is a negative sign number. Now write the difference between the 2 adjacent bits starting from right side to left side. Now 0 minus 0 is 0, 0 minus 1 is -1, 1 minus 0 is +1, 0 minus 1 is -1, 1 minus 1 is 0. Here it is 1 minus 1 is 0. Now we have 1, 2, 3, 4, 5, 6. 6 bits we have. Now you can see here only 5 bits I have written, because if we multiply with 0 also, the same value will be repeated. That's why I skipped the 0 part, because 5 number of bits for the multiplier. That's why I'm using only 5 number of bits. Now we should continue the multiplication process. When we multiply the multiplicand with 0, all the multiplicand bits should become as zeros. So 5 zeros. The leftmost is the sign bit representation. Here the multiplier bits is having both +1 and -1 values. That's why we have to add sign bit extension bits towards the left side. This is sign bit 0. That's why I have to add 5 more zeros towards left side. Now make sure that the total length of the binary bits should be 10, because here we have the multiplicands are 5 bits, multiplier also 5 bits, so that the total is 10. That means in the product we will get the 10 bit length of the product value. That's why we have to append 5 more zeros towards the left side. Now when we multiply with the -1, the multiplicand should be 2's complemented. What is the 2's complement of multiplicand? Now we should rewrite the multiplicand value as 0, 1, 1, 0, 1. 2's complement value means 1, 1, 0, 0, 1. This is the 2's complemented value. Now we should write the 2's complement value 1, 0, 0, 1, 1 and leave 1 bit position towards right side and write the 2's complemented value. Here the sign bit is 1. Now we should extend the sign bit values. That's why 1, 1, 1, 1. Now we should multiply with the +1. So +1 means the same number of bits should be repeated here in the summand part. 1, 0, 1, 1, 0. These are the multiplicand bits. Now here the sign bit is 0, so that 3 more zeros should be extended. Now when we multiply with the -1, again the multiplicand should be 2's complemented. That's why we should use the 2's complemented value as a summand. Now 1, 1, 0, 0, 1. And this is the sign bit, so that we should write the sign bit extension bits towards the left side, 2 more ones. Again we should put side, it is a sign bit 0. Suppose if we use the 6th bit also, again now when we multiply with the 0, the multiplicand bits becomes 0, 0, 0, 0 and 0. Now there is no change by adding the 0 bit at this position. That's why I have missed this left more 0 value. Now adding all these summands to get the final product value. Now here it is 0. This is 0, 1 means 1, 0, 1, 1 means 0, sum and carry 1, 1, 1 means 0 with carry 1, 1, 1, 1 means 1 with carry 1, 1, 1, 1, again 1 with carry 1, 1, 1 means 0 with carry 1, here 3 ones, 1 with carry 1, 1, 1, 1 means 1 with carry 1, again 3 ones, 1 with carry 1. Here this is the leftmost one. We can eliminate this leftmost one while we are using the 2's complement method. Now check the sign bit value of the product. The sign bit is 1, leftmost bit. That means it is a negative signed number. That's why we can understand that the result is in 2's complement form. To check the answer whether it is correct or not, again we should convert the result into 2's complement as in binary weights and then check. Now we should rewrite the result. This is the sign bit as it is. We should keep the remaining bits are 1, 1, 0, 1, 1, 0, 0, 1, 0. Now 2's complement value for this is 0, 1, 1, 1, 0, 0, 1, 0, 0. The sign bit should be same. Now we should assign the binary weights. This is 2 power 0 means 2 power 0 means its value is 1. 2 power 1, 2, 4, 8, 16, 32, 64. No need to assign the binary weight. Directly we should take the negative sign number as 1. Now only add the corresponding binary weights of the 1 values only. Here it is 64. This is 1 bit, this is 1 bit, 1 bit, 1 bit. Now 64 plus 8 plus 4 plus 2. The resultant is 78, but the sign bit is 1. That's why it is -78. Now we should cross check our result with the manual method. 13 into -6 means -78. So that our answer is correct. Now we can check here how many summands will be appeared with this multiplier 1 bit recorded values. Here this is 1, 2, 3, 4, 5 and 1 more 0 also is there. That means totally 6 summands we have. Now with the help of the 2 bit recording, let us see is it provide n by 2 summands or not. N by 2 means 6 by 2 which is equal to 3 summands. Let us move to the second method using 2 bit or bit pair recording method. This is the multiplicand. These bits are equivalent values for the multiplier using bit pair recorded values. Now we should check again the bit pair records for the multiplier 1, 1, 0, 1, 0. These are the multiplier bits. Now append 0 towards right side and append sign bit towards left side. This is a sign bit. Now make these binary bits as groups with 3 bits each. 1 0 0. Now again 1 0 1, right to left, again from this to this one. Now it is 1 0 0 means already we know how to write the bit pair recorded values 0 to 3 and 4 to 7. Here it is 0 plus 1 plus 1 plus 2. These are minus 2 minus 1 minus 1 0. Now 1 0 0 means 4, 4 means minus 2. Similarly 1 0 1 means this is a minus 1. 1 1 1 means its value is 0. These are the values of the multiplier. Now we should start the multiplication process. When we multiply multiplicand with minus 2 means it becomes as minus 2m. That means it should be written as 2's complemented value, but the 2's complemented value should starts from 2 power 1 only, because this is multiplying with the 2 power 1 only. That's why you should write the 2's complemented value only from the 2 power 1 position. That's why in the 2 power 0 position, we should keep always 0. These are the 2's complemented value of the multiplicand. Now multiplicand is 0, 1, 1, 0, 1. 2's complemented value is 1, 1, 0, 0, 1. This is the 2's complemented value. So always the 2's complemented value should start from second position and right towards left side. Now check the sign bit is 1. That's why we should add sign bit extension. Here already including this 0, we have 6 bits, so that only 4 more ones are required. Now let us move to the multiplication with the minus 1. Here minus 1 means it becomes as minus 1 into m. That means the multiplicand should be written in 2's complement form, be starting from third position. The reason is it is a bit pair recorded procedure. That's why we should leave one pair of bits towards the right side from the third position only. Now, when we multiply the multiplicand with minus 1, it becomes as minus 1m. That means it should be 2's complemented value and should start from 2 power 0 position. That means no need to insert 0 towards the right side. Start writing the 2's complemented value of the m from this place, 1 1 0 0 1. This is the sign bit value, so that we should add 3 more ones towards left side. Again, we should multiply with 0, then all the 5 bits becomes 0. Now, this is the sign bit, so that we should append 1 more 0 towards left side. Now, add all these summats to get the final product value. Then 0, 1, 1, 1 means 0 with carry 1, 1, 1 means 0 with carry 1. This is 1, 1, 0, 0 means 1, 1 means 0 with carry 1. 3 ones means 1 with carry 1. 3 ones means 1 with carry 1. 3 ones means sum with carry 1. The leftmost bit can be avoided. Now this is the result of the product. Now you can check the leftmost bit is sign bit. It is 1. That means a negative signed product value. That means the result is in 2's complement form. That means again the same way as 1 bit recorded procedure. Now again to check the answer, we should convert the result in terms of 2's complement and assign binary weights and add the corresponding binary weights of the ones. Then we will get the same answer as minus 78. Now we should check how many summands we have obtained using this bit pair recording method. Here only 3 summands. This is the first summand, this is the second summand, this is the third summand. That means here we have 6 summands, but here we have only 3 summands. That means n by 2 summands. The procedure how to reduce the number of summands to n by 2 summands with the help of the bit pair recorded method, and also in this way we can reduce the number of summands, means we can increase the speed of operation of the multiplication only within 3 steps. So this is the both multiplication of 2 numbers using 1 bit recorded value and 2 bit recorded method. Thank you.